In this video, we're going to talk about inverses. But before we talk about inverses, we want to talk about what is called a one-to-one function. A one-to-one function is a function where every range value maps back to exactly one domain value. Because it is a type of function, that also means that every single domain value must map to exactly one value in the range. So I want to be able to determine if the following are one-to-one functions. Now, we can tell from A, it is a function. Every single value in the domain maps to exactly one value in the range. But does every range value map back to every single domain? And it doesn't look like the case, because it looks like -3 is being mapped back to 1 and being mapped back to 5. So this is not one-to-one, since -3 in the range maps back to 5 and 1 in the domain. Now, let's take a look at B then. Again, looks to be a function. Every single value in the domain maps to exactly one value in the range. Does every single range value map back to one value in the domain? And the answer to that is yes. So it is one-to-one, since it is a function and every range value maps back to exactly one value in the domain. So that is an example of a one-to-one function. Now, what I will do below here is to graph relation A on the coordinate plane. So these are the 3 points from A. Looks like 1, -3, 5, -3, and 2, 2. Now remember, we talked about how 2 different domain values go to exactly the same range value, and that was -3. So what type of line can be drawn in between them? Well, a horizontal line. So notice the horizontal line is touching this relation or this picture more than once. What is that telling me? It's not a one-to-one function. So this is what is called the horizontal line test. So the horizontal line test is a function, is a one-to-one if no horizontal line intersects the graph more than one point. All right, so let me sketch a couple of examples and let's see if we can determine if these are one-to-one functions or not. I'm going to start off with a basic parabola. Now, very quickly, can I draw a horizontal line that's going to touch the graph more than once? And the answer to that is yes. Okay. There's my horizontal line. This is not a one-to-one function. Now again, students will say it fails a horizontal line test, but really what does that mean? That means there are range values that go to 2 different domain values, as I'm hitting here and here. That's what the horizontal line test is really telling us. Okay, so let's come up with one other picture that I want to draw quickly. Okay, I'm going to try to draw the rational function. Now keep in mind that is not going straight up or straight down or left or right for this. This is an example of a one-to-one function. Okay? There is no vertical line to begin with I can draw that would touch this graph more than once, aka it's a function, but then also there is no horizontal line I'm going to be able to draw that would touch this graph more than once. Again, make sure you understand what it means with the vertical line test and the horizontal line test as such. So now we can begin our discussion dealing with inverses. So the inverse function of f, which is f to the -1st, symbolically, is a function where the domain and range are interchanged. Important note to make here, a function must be one-to-one in order to have an inverse. All right, so now I'm given A. I want to be able to write the inverse of A. Well, according to this then, A inverse, I'm going to interchange the domain and the range. So if it's 1, -3, then that should be -3, 1. Well, 4, 4, that's nice. The domain and the range value are the same, so the inverse is going to also be 4, 4. And then the last one's going to be 0, 2. Okay. And again, we can notice very quickly that the original A is a function, and it is, more importantly, a one-to-one function. Here, notice its inverse is also a one-to-one function. Now, B, on the other hand, take a look. B is not even a function because the 1 in the domain is mapping to the 1 and the -2, okay, two different range values. Okay. So because this is not a function, not even a one-to-one function, there is no inverse here. So if it is not a one-to-one function, we might have to restrict our graph to make it one-to-one. Now, let's take a look back at A then for a minute. The domain of A, well, that's 1, 4, and 2, right? So where else do I see 1, 4, and 2? Well, it is the range of the inverse. Now, the range of A, that's -3, 4, and 0. Where else do I see -3, 4, and 0? In the domain of A inverse. Okay. So it's very important to know the domain of A is equal to the range of A inverse, and the range of A is equal to the domain of A inverse. Okay. Now, what I would like to do is to graph this below. As you can see here, I have graphed the original in black, and I've graphed the 3 ordered pairs of the inverse in red. Now, what do you notice? It looks like it is symmetrical across something, right? Because the 4, 4, it's exactly the same ordered pair as its inverse. Well, it looks like it's going to be symmetrical across this line that I'm drawing in blue here. Okay. Notice this point in black is symmetrical to this point in red, thanks to this line, and this point are symmetrical. Now, do you remember the name of this line, where it's f of x is equal to x? This is the identity function. So the graph of the function and its inverse is symmetrical to the identity function, which is f of x is equal to x. Okay. That will come in very handy for us later. Now, what I would like to do is to graph the square root function from 0 to 9. Well, before I do that, I want to be able to graph the original function first. I'm going to do that in black here. So that's 0, 0, and 1, 1, and 4, 2. And then we know 9, 3. So we know what that looks like. Now, here are the points that I used. Well, if I want to graph the inverse, you already know how to do that with a set of ordered pairs. Interchange the domain and the range. So in blue, I'm going to write these points first, and I'll graph them in blue on the number line. So the same and the same. So now I go 2 and 4, and then 3 and 9. Okay. And again, you can tell that these two graphs are symmetrical across f of x is equal to x, or the identity function.